Cl negative aqueous. So Ag plus aqueous plus Cl negative aqueous, because it is still very slightly soluble in water. So when I add AgCl solid, so there will be some. So if I, for example, again like it was for a weak acid, if I add like a lot of AgCl, only a small amount we can take as X will dissolve. So if X dissolves, then we get X of this and we get X of this, because X is the amount of AgCl that is dissolving, that is dissociating into ions in solution. So what happens is what happens is this, and now let me give you another example. So before that let's do solubility product. So firstly you need to know about a saturated solution. So a saturated solution of AgCl will be written as AgCl aqueous gives Ag plus ions plus Cl negative ions. So now it is saturated because if I add more solute to this, which means if I add more of AgCl, then what happens is that it will not dissolve, because when it is saturated, it is the highest amount. So AgCl beyond this will not dissolve. So if this is X, the concentration, so this will also be X, this will also be X, because this is basically the amount that is dissolving. So let me write, let me make this correct. So actually the reaction that takes place is this, but when I add a lot of AgCl, only X amount will dissolve, X amount of the solid will dissolve to get X, to give X of this and X of this. So in simple terms, the X amount of solid that is dissolving is AgCl aqueous. So the X amount of AgCl aqueous gives us X amount of Ag plus and X amount of Cl negative. But this is the equation that we need to learn. So this was just for your understanding. The second one was just for your understanding. So now what is solubility product? So solubility product is the equilibrium constant, is the product of the concentrations of each ion in a saturated solution of a sparingly soluble salt at room temperature, which is 298 Kelvin, raised to the power of their relative concentrations. So in simple words, it is the equilibrium constant. It is written as Ksp Ag plus, concentration of Ag plus, into the concentration of Cl negative. So in this case, because you have taken AgCl, so I'll write it in terms of that. So it is the concentration of Ag plus multiplied by the concentration of Cl negative, and they are raised to the power 1, because as you can see over here, this is all of it is raised to the power of 1, because this the stoichiometric coefficients of both Ag plus and Cl negative are 1. So this is it for Ksp. There is no denominator, because as I said, solids cannot be included in the equilibrium constant expressions, because solids have no concentration. So their concentration is taken as unitary or 1 unit. So we do not have any denominator, we only have a numerator. So this is called the solubility product, and this is the definition of solubility product. But now sometimes what happens is that we have, instead of AgCl, let's take XY2. So XY2 is nothing but it's let's not take XY2, let me take a better example. XY are very like, I was taking random elements, but let me give you PbCl2. So first, before we do PbCl2, now in this case I said, in the case of AgCl, I said that X amount of AgCl dissolves to get X of this and X of this. So Ksp will be X times X, which is X squared. So this is equal to X squared. So this will be nothing but the concentration of AgCl aqueous, or the concentration of Ag plus aqueous, or the concentration of Cl negative aqueous in a saturated solution of AgCl, and it will be squared, because X times X is X squared. So it will be X squared. Now I have PbCl2, which is another insoluble or sparingly soluble salt, as you call it. So PbCl2, if I have to write an expression of it dissolving, it will be Pb2 plus aqueous ions.